Suppose that we know the shape of a line, its slope going up 5 for every 3 that it goes over, and we know that it goes through the point 1 comma 2. Well, if we know those two things, we can click that together and use what's called point slope form to generate an equation of what that would look like. So we can go to this formula right here, y minus y1 equals m times x minus x1. And we're going to use this whenever we know a point on the line and its slope. And sometimes we can get that slope. If they give us 2 points, we might get that slope. Um, x1, y1 is any known point, and m is the slope. The form is especially useful when we're writing an equation of a line from 2 points. And you can convert this to slope-intercept form by distributing and solving for y. We'll do that in some of the examples. Either of the two given points can serve as x1, y1. It actually doesn't matter. They both give the same line. So any point on the line combined with its slope will work. Okay, so let's do some examples. It says, write the equation of a line with slope 3 through 2 comma 5. So we just take our equation of y minus y1 equals m x minus x1, and we're replacing where we see a y1, where we see an m, and where we see an x1, because we have all three of those pieces of information. So we could put in for y1, you see how this is x1 and y1. We can put in for y1 a 5. That'll be what goes here. And then the slope, it said that the slope was 3. So let's give that slope of 3 a position right over here. Then we're going to take x1, which is 2, and 2 is going to go here. And notice that I put these in parentheses. It usually doesn't matter, but anytime that you do a substitution, it should technically be in parentheses. And then those parentheses will go away. We're not actually going to need them in most cases. But that is what gives us our equation. Y minus 5 equals, we'll just leave the 3 on the outside, and then x minus 2. Now, if we wanted to change this from being in slope intercept form the way it is right now into being, point slope form the way it is right now, if we wanted to change this from being in point slope form the way it is right now into slope intercept form, what we could do is simply distribute that 3. So the 3 multiplies to the x and to the negative 2. So this is going to be y minus 5 equals 3x minus 6. And I can add 5 to both sides. And what this does is it gets y by itself, right? So now I have y equals 3x plus minus 1, because a negative 6 and a positive 5 combines to give us a minus 1. So this is another way of writing it. This is probably an easier way where we have the slope and then the intercept. So this is another form. But we often start with the point slope form to do our substitutions because we are given a slope and we are given a point. So we'll start here and then we'll just move it around until we get it into a slope intercept form if that's what they ask for. We have another example here. Write the equation through -1, 4, and 3, -2. First find the slope, then apply the form. So here we didn't get the slope directly. We have to find that slope. So we're going to go ahead and find that slope here by substituting those values in to the slope equation. We covered this in the last video. If you want a little bit more elaboration on that, you can go to our other video. And this is going to be m equals, we're replacing the x, we're replacing the y2 minus y1 and x2 minus x1. One at a time. Let's go ahead and do that this time. So y2, what was y2? That was -2, right? So we're going to put that in as -2 in parentheses. And then y1 was what? y1 was 4. x2 was 3. And x1 was -1. So let's go put a -1 in there. Now, when you have minus and negative, that really turns it to a plus. So this would be -6 over +4, which is -3 over 2. Because they're both divisible by 2, right? 6 divided by 2 is 3. 4 divided by 2 is 2. So this is a simplified way to write that. So the slope is -3 over 2. And now we can substitute that. You can see that that was substituted here as the slope. And it doesn't matter which point you use. Again, you could use either one, but this time we used this point, and that's how we got that answer. You're given a slope and a point, you can convert that into an equation. That comes in handy for calculus. This leads directly into calculus. We're going to be using this. We can model any linear simulation as long as you have one known point of data and a rate of change, which is kind of interesting because there could be an infinite number of points, and you can predict them all as long as you have one point and know the trend. And we use this as a conversion between different forms of a line. So that's pretty much where this shows up. If you are a Palm Beach State College student and you have more questions, don't forget to come visit us at the Student Learning Center. That's where you'll find tutors like myself and my colleagues. We're there on all 5 campuses and 7 days a week online. So I will have a link to that in our description, and see you there.